So, yeah, guys, how are you all? I hope you all are fine and safe. Okay, so I'm Man Gupta again, again welcoming you all in my video. So, what we are going to evaluate today? Well, again, I have three boards with a lot of chalks over there, and what we are going to do is to evaluate a very classic integral. No, it's not Gaussian integral. It's Dirichlet integral. If you're not familiar with that, let me just make you. Just because that is like wow, man. Like I love this integral after the Gaussian integral. Well, this is the integral. Well, more precisely, it's from negative infinity to positive infinity of sine of x over x dx. So this is called the classic Dirichlet integral. Well, when you just have a look at it, like we have the integral from negative infinity to positive infinity, that's good. We have the integrand as sine of x over x. So we have a trig function and an algebraic function. Okay. So after just having like looking at it, we cannot use u sub obviously, and by parts. So it's gonna kill you. Don't do that, man. Please. And partial fraction, of course not. So what we are going to use is our legendary the Feynman technique. So we are going to evaluate this integral with Feynman technique, and I am going to just evaluate it in front of you guys, and I'm damn sure that if you are going to watch this video until the end, you are going to be understand each and every step very deeply, and you can do it by yourself. But the condition is you need to watch this video maybe at 1x or 1.25x, it's your choice. Okay, I think I should begin with, before I start, I just want to tell you that today onwards I'm going to just make a video on the evaluation of zeta of 6, and what's this zeta of 6 is just the Riemann zeta function of 6. More precisely, it's the sum, like zeta of 6. So what we are going to evaluate is this sum. Okay, this is the Riemann zeta function of 6. So not in this video but the next video, and you will have it. We will have it, right? It's not gonna take time to just level it's 1 from 1 to infinity of 1 over n to the 6. Well, let's not talk about this in this video, and what you talk about is this. Well, and I'm thinking that I can evaluate this, but I have never evaluated the cosine of x over x. So I'm thinking that maybe I should do it in this video. Okay, anyways, let's do it before any kind of time is spent. So let's just say that I have the integral as I from negative infinity to positive infinity of sine of x over x dx, right? Well, when you see that sine of x is is an odd function, and x is also an odd function, so these both are going to cancel the negative signs, and they're going to be an even function. So we would have 2 times the integral from 0 to infinity of sine of x over x. And if you're not clear with it, let me just make you clear. As I told you that I'm gonna make you explain each and every step. So to explain, so an integral from negative a to a of f of x, and if f of x is an even function, then this is going to be evaluated 2 times the integral from 0 to a of f of x And how you check that f of x is an even function or not? And well, just put, you have f of x, right? Just replace x with negative sign, negative x. So we have f of x as negative x, and if it's going to be evaluated at f of x, then its function is even. But when your f of negative x equals negative of f of x, it's odd. And I have just taught you the case of this function. When we are evaluating from negative a to a, it's just 0, right? So we are talking about this function, right? So okay. And now what I'm going to do is to define an integral, a parameterization, right? So we have I of alpha as the integral from 0 to infinity of sine of x over x. Well, I think, well, look, when I just, when I tried it out firstly, I thought that I think I should have sine of alpha times x right here, so that I would have an x when I just differentiate with respect to alpha, and x at x would be cancelled out, and then my integral would be so easy. So for your convenience, I'm just gonna tell you with that way also, but that way is undefined. That's let me tell you, I cannot say that, like I cannot explain you by my mouth, but by my chalk and your vision. So for instance, I'm just gonna have this thing, right? dx, right? Well, you can see that I of 1 is just our target integral I, when you just replace alpha as 1. So we had well, it's I over 2, right? When you just replace alpha as 1, so this is going to be I over 2, so 2 would be multiplied both sides, and you have 2 times. Well, I hope you understand. So what we are going to do is, we have our I of alpha as the integral from 0 to infinity of sine of alpha x over x dx. So just derivative of both sides with respect to alpha, we have d over d alpha times the integral from 0 to infinity of sine of alpha x over x, and we have dx. Well, it's total derivative, but we have some functions like this function which is not belongs to like alpha, so it's going to be partial derivative inside the integral. So this becomes I prime of alpha, and what this is going to be is just the integral from 0 to infinity of like partial derivative of sine of alpha x over x dx. So I prime of alpha is just the integral from 0 to infinity. When you just take the derivative of sine of alpha x with the chain rule, because we can't differentiate this thing just because it's not belonging to alpha, it's not alpha a function. I hope you understand that it's not a big deal. So due to the chain rule, we have cosine of alpha x, and 1, when you just take the derivative of inside the sine function, you would have, with respect to alpha, you would have x as left, we had x in denominator, and we had dx. So successfully we have cancelled out x, and we are just left with I prime of alpha as the integral from 0 to infinity of cosine of alpha x, right? Okay, everything is going so far so good, but when you just integrate this thing, you would have 1 over alpha times sine of alpha x, and when you just look at the limits, it's infinity. Like you would have a function 1 over alpha sine of alpha times infinity and minus sine of alpha times 0, which is 0. So this is undefined, and that's why we got stuck when you just use this parameterization. So then how can we do that? Let's do that. why I'm here. I'm going to explain you guys. Just relax. Let me just erase all the stuff. I hope you understand that why we cannot do that, that parameterization or that like how why we cannot let that integral as I of alpha. Okay, let me just have some changes here. So we have sine of x, right? And now I'm just having e to the negative alpha x. And now I think you guys are shocked, most of you maybe, just because why you introduce this thing, like it doesn't make any sense. Well, you're right. Well, we have, when you just put alpha as 0, we would have I over 2, right? So just keep remember that. And now we are going to just take the both side derivative, right? And this is going to make our life easier. So we have I of alpha as the integral from 0 to infinity of sine of x over x e to the negative alpha x dx. D over d alpha of I of alpha d over d alpha of the integral sine of x over x e to the negative alpha x dx. This is going to be I prime of alpha. We have the partial derivative of sine of x over x. Well, I think I should write in such a manner. Oh, sine of x over x e to the negative alpha x dx. So we have I prime of alpha as, when you take the partial derivative of this function, we would have the integral from 0 to infinity of sine of x over x e to the negative sign. Understand, man, guys, you need to look at it. When you just take the derivative of e to the negative alpha times x, you would have like a derivative of e to the negative alpha x is just negative times e to the negative alpha x, right? So that negative sign, I just put that thing right outside the integral, and we are left with e to the negative alpha times dx. Oh well. With the chain rule, we would have x, right? So we are ending up with this thing. So this thing and this thing will cancel out, and we are finally got a better result, negative the integral of sine of x e to the negative alpha x dx. And now what we are going to do is to just use pi parts, and that's gonna make our life easier, man. Okay, let me just copy that. I prime of alpha as the negative times the integral from 0 to infinity of sine of x times e to the negative alpha x dx, using di method, plus minus plus. So the derivative, we are just going to take the derivative of e to the negative alpha x. That's a good thing. And the integrating is sine of x. So when you take the derivative of e to the negative alpha x, what we are going to left with is just negative e to the negative alpha x, as we just understand there, right? Understood there. And the integral of sine of x is just cosine of x, and the integral of cosine of x is just negative sine of x, and this thing is just going to be like alpha squared e to the negative alpha x. Okay, I think, wait a second guys, I think I did something wrong or something. Like the integral of sine of x is negative cosine of x, right? And the integral of cosine of x is sine of x, right? Well, it's not a big deal, but what about this thing? like the derivative of e to the negative alpha x is with respect to x, right? We are going to take the derivative with respect to x, so we would have left with negative alpha because of the chain rule. Yeah, that's good. Now it's good. I hope you understand that, guys. I hope you understand that. And now, just this method is going to make our life slightly easier. Well, not slightly, but yeah, it's going to make our life easier. So we got left with like I prime of alpha time equals the negative times negative e to the negative alpha x cosine x negative alpha e to the negative alpha x sine of x. Well, if you can't see that, I will write down there for your convenience. And in the integral, well, it's going to evaluate it from 0 to infinity, and inside an integral, negative alpha squared, the integral from 0 to infinity of e to the negative alpha x sine of x dx. Let me just check, right? I hope you can see that. Well, maybe. Okay, I think I should erase something. I think I should erase this part. Yeah. And then just write those things. I hope you guys understood this thing. And if you want to take a screenshot, then zoom it and just take a screenshot, right? Yeah. So we have I evaluated I prime of alpha as the negative times negative e to the negative alpha x cos x negative alpha e to the negative alpha x sine of x getting evaluated from 0 to infinity, and we have negative alpha square times the integral from 0 to infinity of e to the negative alpha x sine x dx. Well, if you can see that this is the I prime of alpha, so so negative alpha square times I prime of alpha would be just going to left hand side, and we would have I prime of alpha plus alpha squared I prime. Well, my chalk is not giving support to me. I have to change it. I prime. Well, I think I should erase all this thing. Yeah. So just remember that. Let me just write down there I of 0. Right? Yeah. So we have I prime of alpha plus alpha squared I prime of alpha. Just take out e negative. Well, negative times. Well, let me just take it out, right? Cosine of x plus alpha sine x. Just taking out the negative e to the negative alpha x outside just because this is common inside that bracket. So we are left with this thing, right? So, and the negative times negative is just positive, so this is going to be cancelled out, and we are just taking I of alpha, I prime of alpha as common. So we would left with 1 plus alpha squared, and here we are like this. Just put the values of x, like the limits of x. So here we have e to the negative infinity times cosine of infinity plus alpha sine of infinity, and minus e to the 0 cosine of 0 plus alpha sine of 0. Well, e to the negative infinity is just 0, so this thing is going to be 0, and sine of 0 is 0, so alpha times 0 is just 0. Cosine of 0 is 1, so, and this thing is just, so we are left with I prime of alpha times 1 plus alpha squared equals negative 1. This is negative 1 times 1, so it's negative 1. So I prime of alpha negative 1 times 1 plus alpha squared. Both sides just dividing with 1 plus alpha squared. We would have I prime of alpha as this thing. So now we are very close to our answer. Well, let me just erase all these things. I hope you guys don't have I hope you guys are don't suffering to understand anything. So we have successfully calculated I prime of alpha as negative 1 over 1 plus alpha squared, right? So what we are going to do is to just integrate both sides from 0 to infinity to get rid of I prime of alpha and to get the result of that integral. So we have 0 to infinity of I prime of alpha d alpha. We have negative times the integral from 0 to infinity 1 over alpha squared plus 1 d alpha. So this is just I of alpha from 0 to infinity, and on the right hand side we have negative sign tangent inverse of alpha from 0 to infinity. So I of infinity minus I of 0, and we have negative times tangent inverse of infinity is just pi over 2. Well, let me just try. This is 0, and when you just look at I of infinity, we had I as look, remember that I of alpha was the integral from 0 to infinity of sine of x over x e to the negative alpha x dx. And when alpha is infinity, then we had e to the negative infinity, which is 0. So I of infinity is just 0, right? So this is also 0, and we are left with I of negative I of 0 equals negative tangent inverse of pi infinity is just pi over 2. So finally we have I of 0 as negative pi over 2, which is I of 0 is pi over 2, and I of 0 was I over 2. So we have I over 2 as pi over 2. So we have successfully calculated that I equals pi. So this is the result of this integral. Well, it was quite challenging and it was quite good. Even I got somewhere slightly problem in explaining you, but although we did it, and I loved it. Let me just check how much time we took to solve. Oh my god, 24 minutes. It's 24 minutes, okay? It's good. I could have done this in 10 minutes, but I wanted to make sure that if you are going to understand this, if you are going to look at me, you would understand each and every step as deep as possible. But even though if you are having any kind of problem with any step, at any step, just ask me. I would make you, I would explain you everything. So if you are interested, if you are interested to watch the integral when we replace sine of x with cosine of x, then just wait for here. I'm just going to make this video for that also. And well, we know the steps, and I'm not going to just explain you each and every step, but wait if you want to learn some more things. So this was Dirichlet integral, and we are going to replace sine of x with cosine of x, and let's see what type of result we are having. Well, it's not too much different, but still. Yeah, this thing should be cleared also. So, and sine of x. We are going to replace that with cosine of x. Well, it looks the Dirichlet integral when you replace sine of x with cosine of x. Okay. So the same way we are going to perform this integral, just using Feynman technique with the parameterization of this integral. So let's begin. So we have I of alpha as, like, look, I think I should change the limits, just because if, well, this integral is going to be 0, man. I don't need to give any kind of time with it, like, to it. And if you can't understand that, look at this, man. Let f of x as cos x over x. Just imagine that someone gave this question in your examination. You would think that, whoa, it's related to Dirichlet integral, and you have to solve it, man. I'm going to give my 25 minutes to this. But when you look carefully, this is going to be 0. Let me tell you why. Just replace x with negative x. Cosine of negative x over negative x. Well, it's just cosine of x. So we are getting that negative cosine of x over x, which is f of negative x is just negative f of x. I told you the case of this. If there is an integral going from negative a to a, f of x dx is 0 when this relation is satisfied with that. So it's 0. But we are not kid. We are not kid, man. I am a 12th grader. Well, maybe I'm not kid, but I don't want to be. I don't want to end up this video and just making you happy, just feeling you happy that, yeah, we did that. We are going to play with this integral from 0 to infinity. That's what I'm thinking. So we have this is the Feynman technique. Again, just taking the derivative of both sides. Well, it's just I of 0 as I. So the derivative with respect to alpha well, guys, I'm not an expert. Well, let me just turn off the AC. I'm just feeling cold. Oh, dude, what's wrong with you, man? Yeah, I'm just feeling cold, man. Okay. So far so good. I hope you can understand that. It's just repeating. It's just copying the same method we have used in the last integral. And now we have I prime of alpha as the integral from 0 to infinity, the partial derivative with respect to alpha of cosine of, well, don't get too smart, x over x e to the negative alpha x dx. So we have I prime of alpha as the integral from 0 to infinity of cosine of x over x negative e to the negative alpha x dx. So we have I prime of alpha as negative times the negative times the integral from 0 to infinity of cosine of x e to the negative alpha x dx. Just, yeah. So far so good, very fast. Well, just using we are going to do this with DI method. Di plus minus plus e to the negative alpha x, and we have cosine of x. The integral of cosine of x is like sine of x, so we have sine of x. This is negative alpha times e to the negative alpha x, alpha square times e to the negative alpha x, and we have negative cosine x, right? So we have I prime of alpha as negative, well, not integral, man. Well, I love integral, that's why sometimes I got just slipped over integral. And I just, okay, so negative, well, this negative. And we have e to the negative alpha x times sine of x minus alpha e to the negative alpha x cosine of x from 0 to infinity, and we have the integral from 0 to infinity of e alpha squared outside, of course, e to the negative alpha x cosine x dx. You are looking at it, right? So again, this is just I prime of alpha. So I prime of alpha plus alpha squared I prime of alpha equals, just taking out e to the negative alpha outside. So we have, well, negative e to the negative alpha x. We have sine of x minus alpha cosine of x from 0 to infinity. Well, if you can see that, let me just let me just do this on the whiteboard. So we are having I prime of alpha plus alpha squared I prime of alpha with negative times e to the negative alpha x times sine of x minus okay. So when you just put just common out I prime of alpha 1 plus alpha squared negative e to the infinity sine of infinity minus alpha cos of infinity minus, well, it's plus because of this minus, and e to the 0 sine 0 minus alpha cos 0. This thing is going to be 0 as I told you, and this is just negative alpha, right? So I prime of alpha equals alpha negative alpha over 1 plus alpha squared. I hope you can see that. Like on the right hand side we are getting left with negative alpha, and on the left hand side we have a factor of 1 plus alpha squared. Dividing both sides with the 1 plus alpha squared, we would have this. So what should I erase? I think I should erase this thing. Yeah, I think I should do this too. So I prime of alpha negative alpha over 1 plus alpha squared. Integrating from 0 to infinity, I prime of alpha with respect to alpha negative times 0 to infinity alpha over 1 plus alpha squared d alpha. So to integrate this, just put 1 plus alpha squared as t. Limits would be like changing from 1 to infinity. Have a look at it. When you just put alpha as 0, it's 1, and when you just put infinity, it's just infinity. So 2 alpha d alpha is dt. So alpha d alpha is just dt over 2. So, and on the left hand side we have I of infinity minus I of 0. On the right hand side we have 1 over 2 outside, right? And well, let me just do it, man. I cannot jump steps like that. Otherwise you would say that you said I'm going to explain you as deep as possible and you just jumped 2-3 steps. That's not a good thing. 1 to infinity dt over t. So I of infinity is 0. So negative I of 0 negative ln t infinity and 1. Okay. Well, dear, I think something caught me. Yeah. When you just plug t as infinity, you would have an undefined function. I think so. So let's check what's ln infinity is. I think it's just infinity. So ln of infinity is like, look, is just when you just split its x, right? So infinity equals e to the x. So x should be infinity, I think. And that's why, well, it's not 0. That's why this integral, I think, is undefined. And well, it's all right. I hope I didn't mistake somewhere, but I think that I did everything right. Well, dear, yeah, it cannot be valuable. Like, we cannot evaluate it. And when you just have a look, when you replace cosine x with tan x, well, you should try it out. Like I'm talking about. I'm just talking about when you replace this thing with tan x and then you integrate it. Well, I've tried once, but I got stuck somewhere with that. Like when you just parameterize I of alpha as this thing. When you just parameterize with this thing, I got stuck somewhere. Maybe I could do this with some other parameterization, maybe, but when I just tried it out with that thing, I got stuck. So I think it's enough for you today, guys. And well, I have to record another video in which what I'm going to evaluate is this thing. This is and if no, I would not tell you the result. Well, it's very interesting. So just come up for that video also, and I think I'm just going to record that video soon. And for whatsoever reason you like this video, please just make sure to just like it. And well, I'm a maths lover, and I think that I would make you fall in love with this. So just if you want to be a maths lover, if you want to go so much deeper with mathematics, you should follow me. I would not leave you. Well, I'm just a 12th grader student, but it's not just because there are a lot of kids, there are a lot of like small kids that are doing great at mathematics. But when I'm looking at my story, I think I should tell you right now. Well, I was one of those students who just hated maths. Like I was a hater of mathematics. I did never like loving mathematics. Like I did never love maths. But well, when I just got up slightly interesting in this thing, I got up in this, and I would love to do mathematics instead of just going and chilling out with friends, just talking to girlfriend and all those kind of things. I I don't like those kind of things. We have things. I have these boards, and I have a brain, and I have you guys. So that's all we need. That's all I need. Not about anyone else, but I need, and that's all. Well, I'm here to do whatever I want to do, and I'm doing in mathematics. Yeah, that's all I need. Thank you so much, guys. And well, if you want to just listen to my story, and like it was just an overview, but if you want to just listen to my story like deeply, then just request me, like just ask me. I would just tell you that you don't need to request me. You are authorized for this. Thank you so much, guys.